Good afternoon, everyone. Thank you for sticking with me. We don't have a lot of people, but it's good to see you all here. Um, I have been teaching fluid mechanics class for several years, and the motivation for this work came from observing my students' performance in the class. So I'm going to share what I found, what the results were, like how they were performing, and based on that, I made some changes and what those changes are. So I want to share those information. As a teacher, we all want to make sure that we are communicating well. We are telling our students what we know about, basically transferring our knowledge. And for that, there are different types of methods are out there, like instructor-led methods, and on the other spectrum is flipped classrooms, and kind of like a mixture is hybrid classrooms. So if we want to look at the instructor-led classrooms, everybody's familiar with this because I'm sure we all had teachers who prepared the lecture notes at home and then delivered the class materials in a class. And we were good listeners sometimes, but we sometimes dozed off depending on how our teachers were. So the benefit of instructor-led classrooms is that you can control the pace, how fast you want to go in the material, or how slow. But the disadvantage is that sometimes, like I said, if you're not enthusiastic and not bringing up a lot of interesting things, student might doze off, and then it's hard to keep them interested in the topic. So nowadays, there are other types of classrooms which are being tried in different schools and different departments. Those are flipped classrooms. In those classrooms, teacher prepares the material, posts them online. Students get a chance to look at those material ahead in time at home. So they go over the material when they come to school. In the classroom, they spend more time solving assignments in a group, and the instructor gets more time to go around and find out how they're performing. So benefit of it is that they're all engaged, involved, and definitely we hope that this is going to keep them interested about the topic and it will bring benefits. So there has been also different papers coming out who seem to say this type of classroom is working, but how much, to what extent, everybody is positive about it, but it's still something that not everybody is willing to try. But this is definitely keeps everybody more engaged in the classroom. And in the middle of that is hybrid classrooms, where it's kind of like something between instructor-led classrooms and flipped classrooms. So where instructor prepares the material, delivers it in the class, just like the traditional way, but he or she also prepares some lecture materials or assignments which the students can learn from home. So this method actually works also, and some of the instructors have been using it too. I tried this method using my fluid mechanics class too, but this presentation is not about that. But whatever method we are trying to do, what we really care about is how well we are communicating. As an instructor, we always want to say, okay, this is the knowledge, this is the material I would like you to know. So we try our best, but sometimes we do not see exactly the other end, how effectively they are learning it. So it's really key important that maybe you are able to transfer it. You are thinking that you are doing a great job giving the material, saying out the material or describing the material, but how well they're getting it, we need to assess that too. So traditionally, we assess them through the exam scores or end of the year grades. That tells us, okay, they didn't do well or they did well. So by the time the grades come out, we do not have much to do because they're done with the semester. So the other thing that I always try to do is I ask my students questions whenever they come during office hours. How are you doing in the class? What are your struggles? So I find that those personal conversation helps me a lot to understand what actually is the trouble going on, and I can also give them one-to-one suggestions. And through those conversations, I found that students struggle a lot on some of the materials that we cover in fluid mechanics class. And what I found is that in my class, every semester, more than 15% students drop the class. And out of those who are in the classroom, again, 15%, 10 to 15%, sometimes it goes to 20%, fail in the classroom at the end of the semester. So what happens is that if they fail, they have to repeat this class, because this is a class which is prerequisite for many 2 or 3 of our senior level classes. So that kind of like delays their graduation time significantly. I had a student who failed the fluid mechanics class for 5 times. So imagine 5 times means 2.5 years. So he delayed his graduation time significantly. He is probably one of the extreme case, but I do have students who failed it 2 times, 3 times. That's very common in Cal State Long Beach. So if we look at this chart, I'm sure all of you have seen this type of flow chart where we show how we can graduate soon, the students can graduate soon. So fluid mechanics is a prerequisite for one of our 2 of our classes, 364 and 437. So those are like once they finish fluid mechanics only, then they can take it. And of course, once they finish all the 300 level classes, then they can go to senior levels, and then that's how they get the consent to graduate. So that's how they are stuck with this class several semesters, 1 or 2 or more semesters, and then delay their graduation time. So that's why I always wanted to know what is the cause of their, what can I do to reduce that delay time? What is my contribution? So I asked them, whenever my student come to drop the class or to get the signature to drop the class, I asked them, okay, you are dropping, but tell me what I could have done to make you successful in this class. So all of them have said, no, you did a good job. I hope they say the truth. So they always say, oh, you did a good job. I just didn't get enough time to be involved. I did not quite spend a lot of time I needed to do that. So they kind of agreed like they need to spend more time on this class, because as you know, some of the classes do require more time than the other classes. So this is a class where they have to take the classes in combination, where they can allocate more time for study, and they have the other classes which is less demanding in time. I think that combination would be helpful. So I always suggest them, okay, this is what you can do, but by the time they're already finishing up. So I figured out that why they are not performing well, and I found out that the first exam that I gave them, the first midterm, that's where they get stuck. They perform really poorly, and so when they do so poorly, by the time second midterm comes, they recover, even they get 50% in that exam. That's still not good enough for them to improve their scores. Sometimes they get only 10% in the first exam. That's really, really terrible score, and there is no way to recover from that. So I'm sure you know what we cover in fluid mechanics class, but still I wanted to touch base on that. We cover fluid statics, where we talk about when fluid is not moving, how things are moving, what happens, and then we talk about fluid kinematics. That means the principles related to when fluid is moving, what happens. And then the students also learn about pressure variation in moving fluid, conservation of laws, and then conservation laws and boundary layers and dimensional analysis. So what I found is that the struggle they're having in the first midterm is basically coming from fluid statics. So because that's where they have to integrate the knowledge they learned in statics as well as in math to solve those problems. So this is an example just showing a simple diagram. So our students have to find out the force on these curved surfaces. So if I give them this, if I talk about this problem in class, I tell them, okay, this is the curved surface where you have to find the force, and then I teach them that how we would know the magnitude of that force. So I talk about that, okay, you take the curved surface, take the 2 ends, and you can draw perpendicular projection, and then get this bounding area, where you can think like if you could fill this area or the volume with the liquid, then the weight of the liquid would be equivalent to the vertical force component. So as you can see, this diagram that they figured out, first of all, they struggled figuring out this diagram. I repeat the same statement for all of those problems, but still they struggle to find out how to draw those diagrams, and on top of it, really visualizing the 3D concept. then this diagram, once they are created, then the next struggle they have, as you can see, this is not one of our favorite areas. Like, it's not a square, it's not a rectangle, it's not a triangle. So it's kind of like a composite area. So they need to break this one into two parts, like a square or a rectangle, and a part of the square once the quarter circle is left out. So this is where also they struggle. This is really simple math skills. This is where they struggle, and also they struggle when they have to find the moment of inertia and the centroid of those shapes. So I found like they struggle with the knowledge of having the 3D concept, visualizing that, which they actually should have mastered in statics, and they in the math they should have mastered how to find those areas of composite shapes. But because they did not do well in those classes, they barely made C, or came with the letter grade C. And when they were in this class, since they could not visualize well, that's where they struggle, and that's where they perform poorly in the first exam. So that's why I thought, like, what I can do is probably allow them a little bit more time to improve their performance. And my goal was that I want to increase the number of students who would be getting 70% or more, and reducing the number of students who would be getting 60% or less. That means I want to reduce the number of students who would be failing. So for that, what I did is that, okay, they need more time to grasp the material, first to integrate the concept of statics and math in those fluid problems, plus to be able to solve the complicated shapes. So now what I do is that, what I have been doing is that I'm giving a plane surface in the first exam, and by the time the second exam comes, so I give them curved surface. So between first and second exam, there is 5 weeks of time. So you know that 4 to 5 weeks of time, they get more time to practice that material. So I find that that should allow them a little bit more time to understand and grasp the concepts. So the change that I have made is that instead of giving 2 midterms in the semester, I started to give them 3 midterms, making the smaller chunk in each one of these midterms, allowing them more time to practice little material at a time. And the results that I've found, this is a comparison between spring 2015 and spring 2016. This is the comparison between these 2 semesters, is because in both of these semester I had a small number and similar number of students in the classroom. And what you can see in spring 2015, about 6 students got more than 70% in the midterms, and in the spring 2016, 8 students got more than 70%. I still find it exciting because the average shows that average got a little bit better. It's 33.5. So if we look at overall their performance in the midterms, I see that we did not get any improvement in the students who have been doing well, like getting more than 80%, and students who were kind of like 60 to 70%. It did not actually change much. Instead, I see a drop in that. But if the most encouraging part is that the students who got more than got points between 70 and 80%, that actually increased quite a bit, by about 10%. And the students who were getting less than 10%, 60%, that number dropped. So that's kind of encouraging to me. And this is the overall grade for at the end of the final exam, and you can see the same trend. Final exam also shows that the students within this range performance has improved, and students getting less than 60% dropped. So I conclude that making the smaller chunk is helpful for students. That really allows them to understand the material. So that's what I have been continuing since spring 2016. I'm giving them 3 midterms instead of 2 midterms. And the goals that I had, I see that it is definitely being shown in this just simple one semester comparison. So definitely this is a comparison just between 2 semesters. We need to compare more between more semesters, as well as I need to compare students include classrooms where there are more students. This is what I'm planning to do in future. And also, it also depends on the students we are going to have in the class. Sometimes some students come with really higher intellectual ability than the other students. So maybe spring 2016, I just had really good students. I don't know. So it could be all because of that. So in future, what I plan to do is that also to know their background, like what their GPA is and what their scores were in statics and math. I think if I could coin that, then I could really see, I would be able to see really if this 3 semesters effort was really helpful instead of 2 semesters. That's all. I'm ready for questions.